I'm Nick, North Dakota State University, architecture. I'm a fifth year architecture student, and Peter, one of my classmates, is also fifth year as well. Today we're going to go through some of the different structural systems we were looking at through our passive house project. Again, these from an educational point of view, we're not necessarily advising any or supporting any. These are just different ways of benefits and also prohibitive parts of the projects that will go along with these wall systems. So with that, I can hand it over to Peter, get it started out.
All right, so the first wall system we looked at in the studio is just a classic 2x6 stud wall. So this is what most houses are actually built out of. It's just using lumber, 2x6 dimension in a row, and you fill that with mat insulation. And this normal wall construction has an R value of 21. And just in case anyone doesn't understand what an R value is, it's the wall's resistance to any heat transferring through it, or any energy transferring through it. So essentially, the higher R value of the wall, the better it is, and the more efficient it is. Now, like Nick was talking about, this was a design-build studio at NDSU, and we started actually building things quite early in the studio. One of the first things we built was a 2x6 stud wall, and it was in our studio constantly. We looked at it the entire time, and we knew that it wasn't the wall system we were going to use for our passive house for a lot of reasons, but it was something we were constantly testing against. So here's just us building it in the studio. You can see screwing down the OSB, installing typical insulation, and then also putting drywall. And as we can see, that's pretty much the basics of a 2x6 stud wall. On the interior side, it starts with your gypsum wallboard. This is normally we paint the interior finish. Then you have your vapor barrier, or what should be mostly called a vapor retarder, and it prevents any of the vapor or any of the moisture that's in the air from getting through the wall and into your house. You also have your 2x6 lumber, your 5.5 inches of batt insulation in that, and then you have plywood on the outside and a building wrap on top of that. And that's a typical wall system. Now, the good parts about this typical wall system is that the cost. It's inexpensive to build. It's been built for a long time. All these materials are readily available. And so you really get away with the cost. It's efficient too. Again, the materials are out there. You can go out and buy them. Everyone knows how to build this wall system. And it's also very common. So these are the good things. But what's bad about the typical wall system is its performance. It has a very low R value. And so you're losing a lot of the energy you're paying for into your house through this wall system. And again, this wall system is not airtight. If we go back and look at some of the products that are being used in this, we can see most importantly this vapor barrier is just basically a piece of plastic. And any kind of installation errors or even just hanging a picture on your walls can break this air barrier or this moisture barrier and cause a lot of issues with moisture in your house. So now, there is one innovative thing about the 2x6 stud wall, and that's called staggered studs walls. And so what you do is instead of using 2x6 studs, you use 2x4 studs on a 2x6 plate. So this is what this wall looks like. And you can see that it staggers the outside of the stud so that the first one is on the outside of the wall and the next one is on the inside of the wall. This doesn't look like much, but it actually has a large impact on the performance of the wall. Because those studs aren't traveling from the interior to the exterior, that means it's not a passage for your heat to travel through. Of course, wood is not as good of an insulation as batt insulation or other kinds of insulations. So when those objects travel through the entire distance of the wall, it's very detrimental. And here's just another illustration of how that system works. So even with the 2x4 typical wall, there is still a little bit of innovation in it. The next wall system we're going to talk about is the double stud wall. And this wall system is actually the one we constructed for the passive house over on the east side of the building. It's very similar to a typical wall in that it uses 2x4 stud construction with wood. It uses all the same construction methods, but basically you just build two of them.
So it costs more, right?
What?
costs more, right?
And it costs more, yes. Of course. So this wall has an R of 73. If you remember, that's a lot higher than the R value of a typical wall, so it's going to perform a lot better. You can see some pictures of us installing this double wall system at the passive house during construction. You can see here you build one part of the wall like you normally would on the ground, and then you build another one and secure it on top of that. You take a little bit more labor constructing the details of the wall because of course you have to connect two of them together. And then it's just a tilt-up construction like normal. So it's a very familiar wall construction. And here's just a picture of some of the details of that. And if we look at how this wall is constructed, you start with your interior finish. On the passive house, we're using some reclaimed pine. And then you have a 2x4 lumber or a wall that's actually built inside of the double stud wall. So after that 2x4 lumber, you have an OSB sheathing, then your double stud wall that we saw being constructed. Then you have 12 inches of dense packed cellulose. Cellulose is a recycled newspaper insulation, and you can get it in there really tight, and you don't have to worry about settling issues, and it creates a very thick thermal barrier. And then on the outside you have plywood sheathing, and then normally you want to put some 2 to 4 inches of polyiso insulation on top of it. And a couple of things to mention about this is one, the use of OSB on the interior of the wall. And OSB is basically a product with a bunch of wood chips or wood remnants that's glued together to create a board. And what that does is it makes it a vapor barrier within itself. So it's eliminated the use of that plastic screen we saw on the typical wall that was susceptible to breaking and tearing, and replaced it with a much more durable material. It also skips a step in installation. Now, the plywood sheathing on the exterior is not a vapor barrier, and it's actually permeable by water. And what's important about this wall system, and in any super insulated wall system, is that these systems need to be diffusion open. And what that means is that any moisture that's in the wall system will be able to come out again. And this makes sure that it controls the moisture of the walls so you don't get mold or moisture coming into your house. So, real quick, the good things about a double stud wall construction is its thermal performance. You can basically build it to any thermal performance you want. It's a great construction method. It's air permeability, talking again about moisture being able to get in and out of it. And it's a familiar construction method. It just takes a little bit more time and labor. And that's what we see in some of the bad aspects. The labor is more so. We were students ready to do this, wanting to do this, but a typical construction team might not exactly want to build a house twice over. It uses more material, and some of the other problems that can happen when you do a double stud wall is it intensifies some of those construction deficiencies, and they might become more laborious to fix if you do it wrong in the first place. So, the innovative, it's a high-performance wall with old construction methods. Nick?
Okay, I started the TJI wall section. So, if you're familiar with TJIs, basically they're used primarily in floor joist construction. What they are is a piece of OSB with another structural piece in the end. Looking at the profile of them, it would be in an I formation. That's the guide joist coming from. Technical name, TJI, truss joist I joist wall. With these wall systems, you can generally get to about R70. So they're pretty competitive with what the double stud wall Peter was talking about earlier. Typical construction on this, we do an interior finish, however you choose, the can green or red prefer, and then we can also put 2x4 lumber inside it. Then we're going to step into our OSB, our 16-inch or R70, that's our insulation cavity. From there we go, the dense packed cellulose again, plywood on the outside, the polyiso insulation, and again the vapor shield. It's again an open diffusion system like Peter was talking about before. With this system, there might be a couple little drawbacks as we see in the next slide.
Okay, so
Again, it's a good performing wall, just like the double stud wall. Quick construction. Instead of framing everything twice, you're framing it once again. You're standing one piece, and so it goes a little bit quicker. And then there's very low thermal breakage with the OSB between the members. It's got very little thermal transfer between it. A lot less normal. Again, the bad. This system is widespreadly used in Europe. The TGIs over there are rated to be used on an end position. TGIs we sell primarily here in the States. We're only rated to be used in a floor application. So we do run into some code issues here. Not that they won't work, it's just that you need to be able to find the correct ideas for the application. Again, it may be hard to find. We've had some success looking into Canada for it. There's been quite a few houses actually built in Illinois to pass above spec or atwood. So it is a valuable option for people. Again, the innovative, it's a new use for a common building material. We're using something that's familiar to people. Hardware is readily available, but again, we're using it for a different purpose. So now we tend to step into the more of the pre-manufactured wall systems. With these systems, you would send plans of your building. The manufacturer would go ahead and pre-cut your building essentially, and be shipped to you on a flatbed trailer, and it would be constructed panel-wise. Most of these systems are very quick to assemble and stuff like that. So this is a CLT, one of these pre-manufactured systems. A little background behind this. They're usually a Northern European, Scandinavian design. A lot of times they use a 7-layer of cross-lamination in these walls. And they construct a 2-story house with these. And that's about all they use for it. There's no insulation factor on them. That is it. Mostly relying on log cabin style of thermal massing to provide the performance out of this. Again, CLT cross-laminated timbers. With our system we explored, we're getting about an R68 out of it. Give an example of what you can do with these. Because I'm re-engineered, you can get pretty crazy with the shapes and stuff you get out of it. But it's very good for release of weight. Again, some different designs. Again, all pre-manufactured. They call these fly them in. We'll have the crane bring it in, set it in place, if you guys are holding it together. And they really do fly them in. Some of the interior finish on them can be quite attractive. This is the untreated inside of a CLT wall. They can be left exposed like this, or again, they can be finished with any other kind of finished material you want to put on it. These can be very attractive, made out of any type of wood you choose. And again, I'll put it back. So this is showing a 2-story construction. Again, all that's there is the CLT wall, no insulation impact. Now, for what we looked at, we would use the cross-laminated timber in an hybrid that. We're using a TGI wall construction on the back side of that. So our structure for this wall system is the CLT piece. And from then on, all we're providing is an insulation cavity from there out. So again, the cross-laminated timber, we have a 14-inch TGI on the back side of that. Against back cellulose, like before, plywood sheeting, insulation on the outside of that again, and we put a bigger shield on the outside. So, very similar construction until the CLT point. What's nice about the CLT system is that the CLT, again, similar to the OSB, when they are constructed, it provides a vapor shield anyway. So you're eliminating more steps. Also, you're eliminating interior finish steps. So that's one of the great benefits of these. It's good. Like I was explaining before, multiple layers of one layer. So that one CLT wall is doing multiple things for us. Thermal massing. Obviously, it's carrying a lot of energy just like any other wall system. It can be used as a finished product. Also, another interesting fact, these CLT wall systems, they are built primarily out of waste wood that lumberyards do not want. So usually lumber smaller than what you can get a 2x4 out of. These manufacturers are taking that and putting a good use to it. These are cut down anyway, but then just thrown on the wayside. So we're getting a good use out of this product. With that, it is a little bit tougher to get here in the States. There is one manufacturer we were dealing with out of western Montana. that they built a couple schools together. They turned out very beautiful pieces. The cost, it is a little bit more expensive on the front end, but again, you're looking at look at this kind of construction. It's a great option. It's a little bit unfamiliar. There's very few construction firms here in the States that would be willing to construct something like this. Again, the innovative part of this, the structural and finished material is all in one piece, so we're eliminating a lot more steps in construction. Zip walls. These are structured integrated panels, similar to what you're seeing standing at home. At home, right here in Green Crossing is an SIP wall construction home. Great system. We looked pretty extensively in our project for these, but inevitably the double walls construction went out for us. So with these systems, we're getting an R65 out of our construction with these SIP walls. They are all pre-manufactured again. What they are is a layer of half-inch OSB, a depth of EPS insulation, so the white foam insulation, and another layer of POSB inside of that. All pre-manufactured and we're calling in to your site. So definitely can do people in construction with this. Larger scale homes, smaller scale homes. Roof pitches, everything you can do, anything you can dream, these homes can do. They're using both wall panels on the walls and they're using wall panels on the roof. So the whole exterior of this building is made out of this, similar to what you see there. This is a whole roof system being pulled in on top of the house itself. They're in one piece and pulled in. This eliminates a lot of the seam issues you see within the construction. It can be tilted up by hand. Usually a 6 or 8 inch panel can be usually handled by one hand. So they are easily constructed with a crew without much equipment involved. Construction on them. Again, interior finish. You want to put a vapor barrier on the inside of these and make sure there's no insulation inside your wall system. Sit down with on both sides, so whatever depth you need to reach your arm out right. Again, on the outside of that, we're looking at any kind of thermal bridging, and it gives us a little bit more R value. We're going to get another 4 inches of polyiso on the outside of that again. And then again, the vapor shield on the outside, similar to the construction you've seen before. Some benefits, very quick construction. Being told we usually get about a 3,000 square foot home in a week. Once you ship your site, the concrete laid, they go up extremely quick. They're very, very tight. When everything's coming pre-assembled, pre-cut, all the panels will fit together almost precisely. They just take a little bit more taking to be able to get that haircut area. And the prefabrication. So if you can dream it, they can build it. So that it can be a little bit more expensive for getting these pre-cut panels. It's a little bit of an unfair construction for traditional contractors in the States. Again, prefabrication can also be a bad thing. When you get set panels, obviously site conditions aren't necessarily what they always should be. So if you get all these set panels for a certain building, there might be a lot of fitment issues putting your panels together. You always get that last corner. It's always a fight to be able to get that last corner. But again, the innovative prefabrication system, they go up quickly and they're definitely a viable choice. It's becoming more mainstream as the years go on. ICF construction. Anybody familiar with these ICFs? Insulated Lego is familiar with ICFs. They go together just like Legos. They're pretty fun. We personally have put quite a few basements together with these kinds of construction. We were experimenting using these construction to do a full height wall. We do up to 2 stories of these, and it's a pretty viable option. So again, insulating concrete forms. Two layers of insulation, we strap in between, and we put the concrete in there. So corner details, rebar set inside of them. You see the nuts on top of them, and they interlock with one that was set on top of it. So again, it takes very little time to go in and set a basement or even a full house. So here we see some of the cross bracing and also what they call the window bucks. These openings here, they have to be framed so they'll be able to support the concrete that's being laid on those. So it's again just a for your rub overs. This allows you to get a very precise and very tight fitment of your windows in your home. Also, you can see the bracing as we go up. Obviously, you need to brace it, so when the concrete goes in it, it will be pretty accurate. You're using a pump truck to go ahead and do these in whole widths. So you usually do 4 layers of these before the concrete, and do another 4 layers on top of that. Because they just don't want to get too much pressure coming down to the wet concrete on the bottom where it's possible to roll out. But again, it's very quick, it's very fun construction experience. For finish-wise, typical construction of these would be a gypsum wall board or any other kind of finish you want to put inside of it. Use your ICF foam referring to your embedded enough so you have something to capture layer concrete. Again, these can come in very widths inside. However, it gives 4 more inches of extruded polystyrene on the outside of that as well. So with our whole system, you get the good out of it, quick construction, or multiple layers again happening with this. Concrete obviously is forming a very good paper shield. It could be a very good function shield without cracking. It's a structural ability. Again, 2 stories in the system easily go. And the air tightness layer is all embedded within this one thing. For that, there's a lot of high embodied NSA concrete. It takes a lot of energy to make big, hardest all materials, and mix the concrete to get this happening. So if that's value to you, this is might not be crap. Again, cost. Concrete is a very regional product. Cost vary all over the states. So it can be pretty expensive option. And also the low R value per inch within the concrete itself. But once you get the insulation values on it, so basically the depth of insulation, you're getting a much higher R value. And once you keep the concrete warm, that's acting as a massive as well. Again, the innovative has another medical layer of 1 product. So again, it's one of these trends that we're starting to see here. So again,
So, wrapping up our presentation, we've talked about 6 different wall assemblies. We've talked about wall assemblies that are closer to a classic construction method that we've been doing for years. We've talked about wall assemblies that are more new age, a lot of prefabrication going on, a lot of building materials that are combining different elements into one thing. It's easily constructible. You know, we started with the 2x6 wall, which is good. It's proven to work. It's just not very effective. Then we moved on to the double stud wall, which is basically just making that 2x6 wall effective, filling it with a lot of insulation, putting a lot more labor into it, but using a system that works. The TGI is a system that's very familiar to the 2x6 or the double stud, except for it's using a building material in a different way. And this makes construction easier, but again, it's also not quite as proven, and you might have some code issues or some availability issues. CLT, or cross-laminated timber, is a very innovative and beautiful solution that combines a lot of different things that a wall needs to do in one aspect, but it's not very readily available. Of course, the SIP construction is highly prefabricated. The building basically gets printed by something, gets shipped to the site and constructed. But as we talked about, sometimes prefabrication isn't the best solution. And of course, the ICFs are another solution that exists somewhere between prefabrication and a typical construction. But like Nick mentioned, the high embodied energy is definitely a concern. So, that's the end of our presentation. We'd like to open it up to any questions you might have. Hope you guys enjoyed it.
Yeah, I guess the question was a wall thickness issue. I'm just wondering, the deep depth we're getting to achieve our R values, is this effective at that point, correct? Oh, so I see. It's a client issue where the client was values having those wall thicknesses. I guess if you're trying to get the R value out of it, there are different solutions you can go. Call them VIPs, or vacuum insulated panels. They're similar to what they use on the space shuttle. It's very expensive, but again, you're getting a very high R value per inch. Very, very high R value. So if you want to go a thinner wall, you can always do that. Wall depth issues. Usually, people are committed to going with these super insulated walls. We're not seeing any problems with it. It's just kind of an intricate piece. They do provide a couple of cool things though. Within your windowsills, you have that very deep insulation. As you can see here, providing natural sills there. You can use those for different things. You can even go as deep as providing a bench there, just within your wall depth. So I don't see it as a big issue. Square footage wise, yes, you're using more for your footprint in your window, and you could possibly sacrifice some square footage in the home. But again, I think that the trade-off values are still going toward super insulation.
And another thing I think is important to mention, a lot of the cost that's associated with these wall assemblies has more to do with construction costs or the unavailability of materials in the area. So once these things start catching on and people actually start embracing them, it can really drive down that price. And that's something we tried to do with the passive house, was using local materials, using construction methods that were consistent and familiar. And so when you start talking about those things with clients, it starts to help out a little bit.
So what kind of spacing in between the wall? In between the two separate walls, or in between the studs? So in between, usually there's 16 on center. Space, our application, for the depths they needed, between the two walls, we have another.
It's a 12-inch space.
It's a 12-inch total overall. Between the two walls would be roughly 4 inches between the two walls. So 12-inch overall to give you the R values of these passive house systems we have. Again, these wall systems are all tailored to what they're trying to achieve with them. We were trying to reach passive house standards, so again, that's why we went so big. Any other questions? I've got one. Peter. Yeah. As you can tell, Peter went over more of the traditional framing issue. So a stick built, a high labor cost within these systems. So, is there a benefit for going a high cost of labor versus a pre-manufactured system like a steel system?
I think the major benefit for using the high cost of labor is that if something does happen, if it's not designed right, it can still be altered on the construction site. The building is being worked with all the way through the phase in its lifetime. It's not just designed in one instance, printed out, and then constructed. Prefabrication is great, but it tends to really sometimes, destroy the entire life of the building. And prefabrication hasn't been around as long as these other methods. It's not as tested. Not to say that it should be tested, but still, putting labor into a house is something that I think is very important. No, 16-inch spacing.
So yeah, within our double wall system here, we did use 16 inches on center.
Now, actually using 16 inches on center might not be what you would need to do if you constructed it. We were really concerned about the fact that it was an exhibit, and a lot of people were coming through it. Liability issues. But again, depending on an engineer taking a look at it, you might get away with 24 on center. Me personally, I would recommend any kind of framing 16 on center unless you're really concerned about thermal bridging. It's just a small insurance cost. Just a little bit more material to get a little bit more stuff. And it's easier to find studs. Any other questions? So, Nick, do you want to give me a rebuttal?
A rebuttal on the pre-manufacturing. Yeah, well, obviously there's definite benefits for pre-manufacturing. Up front, just the cost of putting the thing together. A lot of these things can be controlled very carefully nowadays with any kind of foundation construction. All that can be very carefully controlled, so we're not having any huge issues that way. Existing site construction can be handled with non-professional. So pre-manufacturing, I think, is definitely a viable option for beyond the future, and can be a very good way to look into it. Yes, I do acknowledge that the labor investment within a home is very important, and it has been very important historically. So if that's more the field you're going for, it's still a great option. But pre-manufacturing, every
But I think you'd agree that every house is different.
Every house is different.
And we're not trying to advocate any one building system. One building system isn't the best. Situations call for different circumstances.
Definitely true. Most homes today are unfortunately manufactured in bulk. They're manufactured just like a car would be. And a lot of times that's not fitting the family, that's not fitting site conditions, and that's not fitting what's just around the building. And that's very sad. It's a very sad future if we continue that line. Basically, we're going to turn into suburbia all across the United States. So, site conditions, every house is different. That's okay. We do not need to bulk manufacturing. Any specific questions? No? All right, well, thank you for your time. Thank you for stopping by. And again, walk through the whole green process. If you have any other questions specifically to pass it up, feel free to come up and talk to us.
Thanks.